Today we're going to talk about a second type of measure for variability. So we talked about the 5-number summary and more specifically the interquartile range as a measure of variability. In other words, how consistent the data is. We had some other measures of the center, but we're going to be talking about now consistency. And the second one that we are going to talk about is called the mean absolute deviation, abbreviated MAD. So there's a couple of very math-sounding terms here. You did the interquartile range, which we abbreviated IQR, and now the mean absolute deviation, which we are going to abbreviate MAD. So the MAD is a measure of variability and it's determined by the average of the distances of each data value from the overall mean of the data. So it's kind of the average distance away from the average, if you want to think of it that way. The average distance away from the average that the data values are. All right, so yesterday we had this heart rate data, and we put these numbers in order. We found the median, and then we found the quartiles, Q3 and Q1. And if you recall, I think our interquartile range for this was 3. And so that was a measure of variability. We kind of said, well, that seems pretty consistent. That's a low IQR, which means it's more consistent. It doesn't change a whole lot. So the MAD is another way of kind of analyzing that. And so we're going to take these same data values, and this time what we're going to do is we're going to go ahead and calculate the average. So again, the data values are heart rates in beats per minute. So that's what we're looking at here. And what we're going to do is get the average of them. So you guys have done the average, add them up and divide by how many there are. So if you add them up, I think the sum of these ends up being 72 plus 75 plus 81, all the way down the list. I think the sum is 614. All right, so the mean will be 614 divided by, there's 8 students here that we're talking about, 8 students, so 614 divided by 8 is 76.75. So you'll need a calculator today. You can certainly use your calculator on your iPad. If you've got a separate calculator, that would be helpful. And so what we're going to do here, just to organize, this table really helps us organize how to calculate the MAD, the mean absolute deviation. We're just going to list that mean all the way down. So we're going to be using this and doing some subtracting here in a second. So just copy that all the way down the list here. This is the average heart rate of those 8 students, 76.75. All right, so now what we do in the next column, I'm just going to stay with purple. All right, what we're going to do in the next column is we're going to figure out the deviation from the mean, okay? So we're going to subtract the data value minus the mean. All right, so we're going to figure out basically the difference between the data value and the mean. All right, so 72 minus 76.75. We're just going to get that difference. Now that's going to be a negative number. That's going to be negative 4.75, which tells us that that person's heart rate was below the average, was below the mean. 72 is below 76.75, so that negative means their heart rate was 4.75 beats per minute below the average. We're going to do that with each one. We're going to subtract the data value, the heart rate, minus the average heart rate. Once again, we have a negative, so this one was also below the average. We're going to continue to do that. Now this one, notice, we'll take 81 minus 76.75, and that one is going to be above the average by 4.25. And let's just continue to do that all the way through. So 76 minus 76.75, so it's going to be negative 0.75. 76 minus 76.75 is negative 0.75 again, so both of those are below. 77 minus 76.75 is just a little bit above by 0.25. 79 minus 76.75 would be 2.25, and 78 minus 76.75 is 1.25. All right, so these again are just the difference between the heart rate for the student and the average heart rate. So now what we're going to do, we basically found the deviation, so now we're going to take the absolute deviation. So mean absolute deviation is what the MAD is. Remember, absolute value is a distance. When we take the absolute value, we're finding the distance away from zero, and distance is always positive. So now we are going to change all of our numbers from the previous column and just make them all into distances. We don't really care anymore if they're above or below the mean. We just want to know how far away they are. Kind of like the distance from the front of the classroom to the back of the classroom might be 20 feet. And if you are at the back of the classroom and turn around and go to the front, it's not negative 20 feet, it's still 20 feet. It's a distance. Distances are positive. So all we do is change the previous column to positive. So change to positive distances here. So we change the deviations into positive numbers. So the negative 1.75 becomes positive 1.7. If it already is a positive, then it just stays positive. Again, it's a distance. So 0.75, 0.75, 0.25, 2.25, and 1.25. All right, so now we have all the distances away from the average. And again, this is called the mean absolute deviation. So we found right now all the absolute deviations. So these are, again, very mathy sounding words here. So absolute deviations. Now we're going to take the mean of them. So once again, we're just going to add them up and divide by how many there are. So if we sum these up in this column, if we sum them up, 4.75 plus 1.75 plus 4.25 all the way down the list, we get a sum of 16. So the MAD will just be, again, the average of the deviations, so the mean absolute deviations. So to get the average, add them up and divide by how many there are. So this is going to be equal to 16 divided by how many students there are. So 8 students. And so that gives us 16 divided by 8, which is 2. So the MAD right here of 2 is another measure of variability, how consistent the data is. The average distance from the mean is 2 beats per minute. Now remember, our IQR of the same data yesterday, the interquartile range of the same data was 3, and we said that was pretty consistent because that's a pretty low IQR. It means there's not a whole lot of change. This kind of verifies that. The MAD of 2 means the average distance from the average is just 2 above or 2 below for a lot of the students. And so this right here, once again, low number, so low number, so low variability, which means that the heart rates are consistent. So it's a second type of way that we measure variability. The interquartile range is one way, and then this MAD, this mean absolute deviation, is another way. Now this one's maybe a little bit more challenging to calculate, but hopefully this table, and we'll put the table in the homework as well, so you guys can do a little bit of practice with that and have it kind of templated for you. If you just kind of go through and think about what each step is, then that should help. All right, so let's just do a little interpretation of this. So for another data set all the values are either 3 beats per minute above the mean or 3 beats per minute below the mean. Is that enough average to find the MAD for the data set? If so, find the MAD. If not, what other information is needed? Explain your reasoning. Okay, so there's a lot of questions at the end of that, but what it talks about is that the values are either 3 beats above the mean or 3 beats below the mean. Well, that's what the MAD is. It's the distance away from the mean. So yes, if all the data values are 3 beats above the mean or 3 beats below the mean, then yes, the MAD, the mean absolute deviation, aka the MAD, the MAD is 3. Because on average, you're either 3 above the mean or 3 below the mean, so it kind of deviates from the mean by 3 beats per minute. So that is what the MAD is calculating. All right, and then the second question, several pennies are placed along a meter stick, and the position in centimeters of each penny is recorded. The mean position is the 50 centimeter mark, and the MAD is 10 centimeters. What information does this tell you about the position of the pennies along the meter stick? All right, so if we imagine a meter stick here, and let's see, we got maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, let's go one more, 10. All right, so it's kind of like each part is going to be 10 centimeters. And we've got 1, 2, 3, 4, 5, so let's say this is 50 centimeters. That means that you're going to have the pennies kind of spread out a little bit. Let's use a different color along. So imagine each one of these, let's use brown because that's a penny. All right, so each one of these pennies is spread out along this meter stick. And what we know is the mean is 50. That's why we marked that first. And we know the MAD is 10 centimeters. So that means the pennies on average are going to be 10 units away, 10 centimeters away from the 50. All right, so we don't know exactly what the numbers are, but we could probably make up a number set. In fact, the one below here, in the Are You Ready for More, you can kind of see if you can come up with something though. So we know, on average, the pennies are located 10 centimeters above or below the mean of 50. So notice that some of those pennies are above the 50 and some pennies are below the 50. Some are to the right of it and some are to the left of it. Some are closer to the 50 centimeter mark and some are farther away. Some are farther. But on average, they're going to be 10 centimeters one way or 10 centimeters the other way. If we average all those distances, each one of these individual distances together, we'll be averaging 10 centimeters away. So for the work at the bottom, I'm not going to go through that in the notes, but if you want to just experiment with this a little bit and see if you can figure out the possible locations of the pennies given the parameters here with 6 pennies this time and the MAD is 10. Find the possible locations for the pennies and find a different set of possible locations for the pennies. Now, just remembering that you're going to want to make sure that on average the distance away from the mean of 50 is going to be 10. So think about how that will work if you have 6 pennies. How will those 6 pennies be positioned? So the average distance of those